Hello. So that alarm I just set, that's the timer trigger that started this presentation. So we're going to dive straight in to some code. So this is a Azure function. If you've used Azure functions, this is just an Azure function. But it's also a starter function for our durable orchestration. So it looks like a normal Azure function, except you'll notice we're injecting this durable task client. And don't worry too much about this. We're going to come back and relook at this in more detail. I'm just going to quickly run through for now. So the function, all it does is this one is just going to log that we're starting the function, and then this, the bottom line here is where we start a new orchestration. And you can see it's a timer trigger function at the top here. We've got a timer trigger set to go off when this starts. So if we follow this code through, we'll be going into this presentation is written in Impress.js, so it's got some like crazy transitions. But fortunately, with durable functions, all we need to do is look at the orchestrator, and that will tell us exactly where we're going next. So this is the orchestration function, and it's the main thing with durable functions. So this basically lists all the stages of your workflow. And so let's run this code. So we call an activity function. This is because when you're using an orchestrator, you can't do anything, you can't really do any real work in it. You just use it to control the flow of your application. And we'll go into that in more detail. So whenever you want to do something like call another function, you have to go via an activity function first. Let's jump into the introduction. So this is the activity function. Again, it's just another Azure function, except we have an activity trigger. And yeah, don't worry if I'm going fast. We're going to come back through this. Don't worry. Let's start the introduction to this presentation. I'm Luke. I'm a Norfolk developer. If you haven't spotted me, you probably haven't. There I was a few years ago. I was sitting there. Now I'm up here giving a talk. I work for a company called Brandbank. We're based in Beaufort in Norwich. I used to work in this office, but that was pre-COVID. Now I work remote, so yeah, my life is more like this. I'm also a scout leader in my spare time, so if you want to talk about that, catch me afterwards. But yeah, enough about me. Let's go back and explore what Brandbank has to do, what they do, and it does relate to this presentation. It's not a sales pitch, I'm not like recruiting or anything. What we do is we get products like this sent to our office from suppliers, and what we do is we photograph like each dimension of the product, each face of the product, to create what's called a label image, and then we capture all the data off the image and put it into a data model that holds all the attributes that you'd see on the product. So we've got like lifestyle information, allergy advice is like a really important one, we like format the entire product. So this is like 1,000 lines of JSON with every attribute that you see on the pack, and even metadata. So we've got like shelf height, shelf width. And then what do we do with all that data? Well, we send it to online supermarkets. So if you've ever done online shopping, Asda, Ocado, Tesco, Sainsbury's, any of like online food retailer in the UK, they use our images and our product data. So we work with basically everyone in the food industry. Anyone that sells food online, will go through us. And it's not just in the UK now, we do it worldwide. We capture all the weights and stuff, so self checkouts, they need to know the weights of different products, and we supply that data as well. So that is the end of the introduction. So we return back to this activity function. We've now completed that, so we go back. So we've completed the activity. So let's just check off that we've done the introduction. And then we go back to our orchestrator function, and this has been sleeping. This is one of the benefits of durable functions, is when a function is not in use, it basically goes to sleep, so you're not paying for it. And then when it's come back into play, it then kind of reawakes itself, and it starts from the start again. So it calls this first line of code to call our activity function of the introduction. But wait, we've just ticked off the introduction. We've done that part. So it remembers the state, and it remembers that. So we don't do that again. So we skip that line, and we come to our scenario. So again, this is another activity function for the scenario. So let's start explaining the scenario. So I imagine most developers, you've come across this. You take some data, you do something to it, you put the data somewhere else. That's most of our jobs, I imagine. I used to work as an integration developer at Brandbank. So that's that same pattern, except you're taking data from one company, transforming it, putting it into Brandbank, or taking Brandbank's data, converting it into a different data model, and sending it off to another company. So at Brandbank, we work with Azure. This, I guess, is a self-portrait of Azure. It was AI generated by Bing, so we have to assume that's accurate. So if you're not familiar with Azure, it's Microsoft's cloud platform. And if you're working with like integration services, you'll be dealing with these kind of applications. So first of all, we have Azure Functions. One of my friends, Kiri, is doing a talk after this one in the main conference hall. So he'll go into more detail about the basics of Azure. So we're just going to cover this briefly here. But Azure Functions are a serverless way of writing web services. So you don't need to worry about setting up IIS and installing Windows and patching it, all that kind of stuff. It just happens in the background. You, for the most part, don't know what's going on or where your code's running. You're just, as we saw the functions earlier, you're just writing a method of code, and then you can run it in the cloud. And you can, it's not just like when people first started using functions, they were doing small bits of code. You can now kind of build up entire libraries and build web apps just with functions. And the benefits of functions are that because there's no server per se, they can scale. So you can keep, if you get more and more requests coming into a function, Azure just automatically spins up new instances for you, and you don't have to worry. And they're also really cheap. Because an Azure function, normally it can only run for 5 minutes. You can extend them to be 10 minutes. But yeah, you're only paying for what you use. I mean, you can put them on the plan where it runs like a normal server if you want, but you kind of lose the benefit of the functions if you do that. We also have queues, which do what you'd expect. You put some data onto a queue, you put some more data onto the queue, the first piece of data, then you can take off the queue, and then the second piece of data in the order that you put them onto the queue. So these work really well with Azure Functions. It's all kind of built in. You've got like a queue trigger. So I briefly showed you like a timer trigger and activity trigger. You can have a queue trigger. And what this does is it subscribes to that queue. So if any data gets put on the queue, the function wakes up, reads that data, executes it. If there's a problem, the queue doesn't actually lose the data immediately. So if your function throws an exception, for example, the queue will kind of retry maybe up to 5 times. So you get kind of built-in retry. If it's not like a transient problem that goes away, then you have what's called a poison queue. So any message that keeps failing repeatedly gets put onto a poison queue, and then if you want, you can build another function which subscribes to that poison queue, and I don't know, maybe emails you to say this data is completely broken, we don't know what to do, something like that. So yeah, queues are like really simple to use, but can be like really powerful for making resilient applications. We also have blob storage. This is a way of just storing data in the cloud. If you've ever used AWS, it's similar to like S3 buckets, except we call them containers, and you create a container and you can just write data to that container. It's really cheap and easy to use. Table storage, it's not really a database replacement, it's like just a data store, like of structured data. You have a key and then kind of rows of structured data, and you can basically write as much data as you want and read it back. It's really easy to use and get started quickly, and if you need to log stuff to it, you can just create a log and just keep adding it to your table storage. I wouldn't really recommend joining like tables together. It's not really designed to do that, but if you've got like one kind of single like format of data, you can just stick it into that table. So that is like Azure services in a nutshell, I guess, for integration stuff. And what we need to do is connect them together so we can build some applications. Fortunately, unlike Homer's barbecue, they do actually go together really easily. So this is what we used to do at Brandbank. We'd have like a function chaining pattern where each function is connected via a queue. So our get function, that would be like a timer triggered function. So like maybe once a week, it would wake up, call into an API, say, have you got any content for us today? And then download some content. It would be like different products, and then write that data into this queue, which means we can like scale the application easy because it can just write stuff to the queue, and then the transform functions, they subscribe to that queue, they wake up and start reading stuff off the queue. They do a transformation, so just changing the data into a different format, and then write it to another queue. And then finally we have a deliver function which reads off that queue and then sends that data into a system. Maybe it uploads it to another API or writes it to a database, something like that. And that was all well and good, except we started running into some issues, of course. So one of the issues is, you might have noticed this data is really long. It's like 1,000 lines of JSON. Queues unfortunately have a limit of 64 kilobytes, so even big JSON files can breach the limit of a queue. And we have a lot of images of Brandbank. The product can have like 10 different images. We use high resolution, like 20 megapixel images. We're quickly, like 100 megabytes of product, and there's no way you can put that onto a queue. Fortunately, what you can do is use blob storage to assist with that. So all you do is write like an ID to the queue. That ID you can use as a key in blob storage for your blobs. For each product data, you write the product content to blob storage, and then you use your ID to then link that to the message on the queue. So the next function reads the product ID of the queue, and then looks up in blob storage to get the actual content. It takes a bit more time to set up, but once you've got that going, that works. And then we decided we needed to know what was kind of going on, what state products were in this workflow. So we got some table storage, so we can then record this product came into our system at this time. We transformed it, and then we sent it to another system at this time. So we built up a record of what was going on. And it was great. We could build all this, but we're supposed to be delivering content. I'm in the integration team. We're not supposed to be building out kind of like our own framework for product distribution. So what do we do? So that's the end of the scenario. If we go back to our orchestrator function now, so this is the actual flow that would happen with orchestrator functions. So it comes back, it wakes up. I forgot to check off the scenario, but it starts again from the start. So fortunately, we've saved that we've done the introduction, we've done the scenario. So we go to our third line, which is durable functions. So again, we call into another activity function for that. And this will hopefully solve our problem. So with durable functions, we can eliminate all these extra services that we've created. So we don't need to think about table storage or blob storage or even the queues anymore. Durable functions gives you that out of the box. So all you need to do is write your business logic. So we just have our get, our transform, and our deliver functions, and we're no longer having to worry about all the extra stuff and robustly testing that our blob storage syncs with our queues and vice versa and all that kind of stuff. We can just focus on doing the transformations. So that was quite mind-blowing for me, realizing that all the work we'd done was kind of duplicated by durable functions. So that leaves us with this pattern. So we still have our get function. That's now going to get product content. If it's got any product content, it's going to trigger an orchestration. So that triggers our orchestrator. So now with durable functions, we have an easy way of processing stuff in parallel. As we'll dive into the code on how to do this, but it means we can then translate many functions, many products at the same time to speed up our system and so on. And then again, we have our deliver. So once all these products have been translated, the orchestrator collects all those results together. Once it's got all of them back, it can then call our deliver function. So another use case of orchestrator functions, I've not actually used this in practice, but it looks really interesting, so I thought I'd raise it, is you can, when the orchestrator goes to sleep, it can go to sleep kind of indefinitely. So you can do things like approvals. So you could send out an email to someone, your orchestrator function can then go to sleep, and then when they click on a link in their email to approve something or activate their account or something, you can send a request back to that orchestrator. It wakes up and continues the workflow. And you're not paying whilst the orchestrator is asleep. So it becomes really cheap to have these long-running services. You don't have to worry about polling or anything. It's just all happens in the cloud by Azure for you. So durable functions allow you to do really kind of powerful things very simply. You don't have to worry about the internals. That is durable functions. So let's tick that off. And our orchestrator wakes back up again. We start at the top. We've done the introduction, we've done the scenario, we've done durable functions. So that means we've finished this presentation part. So let's dig into some code, and we'll go into this in depth. So this is an example that I've put together based on what we've seen. Let's get rid of that. So this is a get function.
Slightly.
Sorry? Yeah, of course, yeah.
Could use the bottom left if you prefer. Thank you.
Yep. Okay, so this is the start of our durable functions. So this is the starter function. So as we saw in the slides, we just write a normal Azure function, but we pass in this durable client. So you create a normal function project in Visual Studio, and then there's a NuGet package for adding durable function functionality. So once you install that package, you then get access to these durable clients. So this, normally we'd call an API to get product data, but in this example, I've hard-coded it in here. So we've just got a few basic products. And then we start a new orchestrator function, and we pass in those products. Okay, so if we jump to the orchestrator now. Again, it's just another Azure function, except we've got this orchestration trigger. So all we're doing is, this context is the kind of backbone of an orchestrator. Anything that's kind of durable function specific comes off this context. So in this case, we can get the input, so those products that we passed in from our get function, we can then get them into our orchestrator. And then what we're saying here is for each product, we call an activity function, and it's called the translate activity function. And then we're using some like async code, so we get a task and we can add this to a list of tasks. So in the slides I showed transformations happening in parallel, those like free functions coming off the orchestrator. That's how you would write this in code. So I'm sure most of you have done some C# and used async await, so it's the same kind of pattern. And then you've got this when all, so you can await all your tasks. And that then wakes up the orchestrator and it will continue. So yeah, at this point, let's show the translate.
Do you want questions during or after?
Sorry?
Questions do you want before or after?
Probably during, if it's, yeah.
So on that previous one,
Yep.
what do you see the benefit of calling lots of the async ones internally rather than having a separate queue with each individual product in that queue, processing them as a separate queue, because then you'd get your poison list of failures. So what's kind of the benefit and what's your failure process in comparison to when you're running it inline in a durable?
Yes, that's a good point. So behind this call, there is a queue. Durable functions queues it automatically. So
it's doing that part for
yes, you don't get the poison queue though. That is one of the downsides. You'd have to wrap this in like a try-catch block and then handle that yourself.
Handle the failures, put that into a separate queue to look at, or?
Yes, yeah.
Another question.
Yeah.
So you're passing in this example a lot of product data. And you mentioned earlier that there was a limit on queues for 64 kilobytes.
Yes.
This magically handled also.
Yes. Yeah. Maybe I didn't explain it enough. Is that this durable functions does what I showed you? It automatically uses the blob storage to basically any message that's over 64 kilobytes. It puts into blob storage for you. You don't need to think. You don't know about the blob storage. You just read it as if it's another request, basically. That's kind of the magic of durable functions. It hides all this functionality for you. So yeah, so the translate, that's just with a really simple example. So all we're doing is creating this description, which is the brand of our product and the description, and then we return it. So this function, just kind of think of it as like a separate function. But it's just an activity trigger instead of being like a HTTP trigger or something like that. And then, so yeah, once they're all complete, we then need to finally deliver them. So we call another activity function with our called deliver. So that is here, and in this example, all that's doing is just logging the description so we can see it works. But yeah, in context, we'd normally save that data there or something. But this is a very simplified example. So let's fire this up. And then, yeah, so if you've ever used Azure Functions, you get this list that shows all the functions in your application, and if they're HTTP triggered, it gives you the URL that you need to call to debug it. So if we copy that, we can fire off a request. And yeah, hopefully, yep, we'll see all these functions firing off. And if you were to follow that, you'd see this pattern where we jump back to the orchestrator and it awakes. But there is a much nicer way than looking at this console output. There is a project called the Azure Functions Monitor. So it is an open source project. I think it was created by a third party, but it's now been moved on GitHub into the Microsoft section. So what that does is it gives you a very nice UI for seeing how your durable functions are going. So in Visual Studio Code, you can host it as a separate application, this monitor, but Visual Studio Code has an extension that gives you access to it. So you'll need to install the Azure extension, and then you'll see you have this durable functions tab. And if we go to our storage emulator, you'll see the orchestration you just created. And you double click on that, and then you wait whilst it starts. It does take a little while. While that's going on, we can actually look in Azure Storage Explorer. We can see the tables that the durable functions are creating for us. So this is what's backing our functions. Basically, it's creating some tables, and we've got like instances and we've got one instance that we just ran just now, and it's showing what's been input. And then if you go on to the history, you can then see what's happened. And then basically this is the durable functions monitor. So this is a UI basically for those tables I've just shown you. So it's much nicer. It shows you the orchestration that's just happened. You can see the products that we input to create the orchestrator. And the output as well. So we were just returning that we processed 3 products. And what you can do is for each instance, you can then click into that, and it gives you more detail to show you what happened. So we translated these 3 products, and then we delivered them. And we've also got these nice diagrams. So a sequence diagram that shows the orchestration starting. We then translate the products, and then finally deliver them. And this Gantt chart shows the translates are happening in parallel, which is quite nice. So yeah, this is really handy for finding out when stuff goes wrong, as I'm about to demonstrate now. So the way the orchestrator works is because it's awakening and starting from the start again, you need to make sure that when it runs through the code again, it does the same steps again, and you don't generate different results, otherwise everything is going to go kaput. So just as an example of what will happen, and you'll probably run into this if you use durable functions at some point. So if I copy this code here and replace this loop, I'll zoom back in again. If I press the right one. Yeah, so now what you'll notice is we've got this code. We're adding a date time to the product. This is kind of a contrived example. Normally you do this in an activity function, but you could do this in the orchestrator if you wanted. And then we're going to add an ID to your product by just generating a new GUID, a unique identifier. And then what we're doing is if this GUID contains an A, then we're calling the activity function. Otherwise, we're not going to process that product. So you may be thinking, yeah, this is going to be generating different values each time this code runs. So let's restart this and see what happens. And it's still starting, okay. Okay, I'll just wait for that to load up. Okay, yeah, so let's fire off another couple of requests. And now if we go back to the monitor, I can refresh that and I can see the new requests we've just created. And some of them will be fine, but a lot of them are now saying that they've failed. And we get this error message as our output. So non-deterministic workflow detected. So that basically means that you're doing something which didn't happen in the past. It's kind of like time travel in a way. You have to make sure that you do everything to create the future. So if we go back to our code, we need to make sure that when the orchestrator wakes up, having processed the product, it comes back into this code, and we get the same values every time. So how do we do that? Well, that's where the context that we've injected comes in handy. It has some built-in methods on it, so we can do context dot current UCC datetime. And that ensures that when this function reawakes itself, it's always saving the same time value that it used when it first ran. And again, with GUIDs, we can do context.new GUID and then just toString on that. Okay, so that again ensures that every time this code runs, it has the same GUID on each instance, and that kind of explains why we need to call this activity async method from the context as well, because we don't actually want that activity to execute again. The orchestrator saves the original value, and then when it replays, it just checks that it's got that value, and then we can skip over it. Because what could happen is, the network could be down the next time it calls that function, and then it would get a different value. So we need to save the results of that. So that's why anything that could change has to happen from the context, so it gets saved properly. So that's it running locally. Obviously, once you've written your code, you want to deploy it to Azure. So I'm not going to go into detail of the deployment. Kiri, as I said, will do that after this talk in the main room. But just as an example, we can see in the Azure portal, this is what you get when you deploy a durable function. It's basically the same as a normal function. And if you're not familiar, I'd recommend using Application Insights. It's basically a logging mechanism in Azure, and that allows you to then debug your applications when they're in the cloud, and you can see then there's a live metrics tab which allows you to see in real time what's going on. And there's not much at the moment because I haven't actually run anything in the cloud yet. But yeah, if that gives you an example of what you'd see if this were running live, you'd see your activities being triggered and stuff like that. So yeah, that wraps up this talk. I hope I've given you like an overview of the stuff that you can do with Azure Functions. Let's just jump back to the slides. Yeah, so thank you for attending. This has been Unlocking Azure's Orchestration Secret, a journey for durable functions. Thanks to Impress.js, Draw.io, Highlight.js, Microsoft, and NIQ Brandbank for all the tools that I've used in this presentation. I hope you enjoyed it and enjoy the rest of your day at NorDevCon.